Hello everyone, today we will continue with the second part of simple machines. In the first part, we were more concerned with the verbal and definition parts of the subject. I believe the second and third parts are more fun. So let's get started then. It's worth remembering that simple machines are there to make our work easier. They are designed to reduce the energy we spend on doing a job. And in order to achieve this, the path and time spent by the force we apply is important. We just mentioned that simple machines are designed to reduce the energy we will spend. Well, then there should be a gain in energy, and we call this gain as mechanical advantage in physics. Mechanical advantage will be a term we will hear frequently in this part. Plus, it's easy to calculate. The size of the work we do is divided by the force we spend on this work. So the charge is divided by force. This means that the mechanical advantage can never be less than 1. If you find the mechanical energy less than 1, you probably must have made a calculation error somewhere. So cannot be less than 1. Well, then let's start with the levers. As you remember from the first part, levers are a hard rod or a rigid bar that can rotate on a fixed point, and we call this fixed point as fulcrum. This is the lever, a rigid bar, and as you can see, the guy applied a force downward in order to move the rock. I divided levers into 3 parts, so let's examine them in order. First class lever, force, fulcrum, and load. This is the combination of the first class lever. Okay, let's continue with an example. And the example says, calculate the force required to balance a load of 700 Newton using a lever 3 meter long. The formula was force times the distance to the fulcrum from the force. So that means 2 meter, and let me write like this. Force distance, and that's equal to, this is our load times load distance. This distance from load to the fulcrum, and this one, as you remember, it's fulcrum. It's a fixed point. So this is our formula, and I'm trying to find the force here. I know load is 700 Newton, and the load distance is 1 meter, and force distance is also 2 meter. How can I find the force here? Force times 2 is equal to 700 Newton times 1. So I can find force from here as 700 times 1 is 700, and divided by 2, it's 350 Newton. What happens if we longer the distance from force to the fulcrum? Let's remember the formula. Force times force distance is equal to load times load distance. Again, I'm trying to find the force. So F times, what is the force distance here? 7 meter. 7, and that's equal to 700 times 1 meter. This is the load distance. So from here, I can find as 700 divided by 7, that's equal to 100 Newton. At the beginning, to lift this load, I need 350 Newton. But if I longer the distance, the force distance, the required force will be decreased as 100 Newton. So let's calculate the mechanical advantage here. Mechanical advantage is always equal to load divided by the force. And load here is 700 and the force I applied was 100, so that's equal to 7. It's better if the mechanical advantage is increased. In the previous example, the mechanical advantage was again load divided by the force. Load was 700 divided by the force I applied 350 Newton. So the mechanical advantage was just 2. In this combination, second class lever, it's like this: fulcrum, load, and force. Again, we have the same formula. Basically, in all simple machines, we have the same formula. Okay, let's continue with an example. A man carries a 300 Newton load using a wheelbarrow. What is the force the man applies for the values given? Find the mechanical advantage of the wheelbarrows. So my formula was F times force distance, and that's equal to load times load distance. So I'm looking for F here. What is force distance? The force distance is equal to 150 centimeter plus 50 centimeter, and that's equal to 200 centimeter, which is equal to load times load distance. And my load is 300 Newton times load distance, and the load distance is equal to 50 centimeter. So I was looking for the force. Force times 200 centimeter is equal to 300 times 50 centimeter. Let's convert this centimeter into meter first, and then we apply the formula. 200 centimeter is equal to 2 meter, and 50 centimeter is equal to 0.5 meter. So that means that F times 2, 300 times 0.5. And from here, I can find my force as 150 divided by 2 as 75 Newton. So what is the mechanical advantage here? And the formula of mechanical advantage was load divided by force, and load was 375 Newton. So my mechanical advantage is equal to 4. Let's continue with the third class lever. Again, we have fulcrum here, force, and load. This is our final combination in levers. Let's look at the example. Find the mass of the object. Let's write the formula first. F times F distance is equal to load times load distance. I am trying to find the weight of the load. My F is 120 Newton. The force distance, this one is force distance, 2 meter. And I'm looking for the load. And the load distance is 1 meter plus 2 meter is 3 meter. So I'm looking for the load here. 120 times 2 is equal to load times 3. And load is equal to 240 divided by 3, and that's equal to 80 Newton. If you remember the formula of weight, weight was equal to mass times gravity. So mass is equal to 80 Newton divided by 10 Newton per kilogram. Mass is equal to 8 kilogram. Let's continue with the pulleys. There are two kinds of pulleys. The first one is fixed pulley and the other one is the movable pulley. It does change the direction of the force. Nothing else. Force is equal to load here in fixed pulleys. Let's continue with the example. If the force we applied is 200 Newton, what is the mass of the load? Again, G is 10 Newton per kilogram. So the formula was F is equal to load. And that means that if force is equal to 200 Newton, that means load is also equal to 200 Newton. So how can I find the mass? Again, weight is equal to mg, which weight is equal to load here. So I'm looking for the mass. Mass is equal to weight divided by g, the gravity, and that one is equal to 200 Newton divided by 10 Newton per kilogram, and that's equal to 20 kilogram.